In this video, we're going to learn about function composition. We use the function composition when we have two or more distinct and complete operations that need to be performed on the input. That means that first we need to do the first operation on the input, and then take the output from that operation and do the second operation, etc. The two or more composed functions happen one after another, each operating on the output of the previous function. Each operation in a function composition is a subtask of the original problem, which is why we want to decompose our solution into multiple functions. Let's first consider the domain for this example. This example considers water quality measurements and ratings that are made public by the Government of Canada. The particular set of information that we're using is from fresh water quality measurements in 14 streams and lakes in the Pacific Rim National Park Reserve on Vancouver Island in BC, Canada. 46 water quality parameters are provided for each measurement, and each measurement is ranked using the Canadian Council of Ministers of the Environment Water Quality Index. We've created a compound data type named water quality to store the information from one sample. It includes the location, year of sampling, water quality index, which ranges between 0 and 100, temperature in degrees Celsius, pH, which ranges from 0 to 14, and the dissolved oxygen level. You can see that we've created a number of examples, and as I scroll down, you can see the template. We've also created a data type for a list of water quality ratings. The problem that we want to solve is to design a function that takes a list of water quality ratings and a location, and returns the average water quality index at that location. We're starting with a stub, including signature and purpose. We have to consider the case that the location given is not represented in the list of water quality. In that case, you can see that we've decided to return none. Using optional float as a return type gives us a way to specify the special case that the location does not exist in the list. If we had instead returned 0 in this case, it would be impossible to determine whether the average was 0 or whether the location was not represented in the list. We've also written some examples. The first example is the empty list, and we expect the function to return none. We then have two examples where the list is of length 1, one where the location doesn't exist in the list, and one where it does. Finally, we have a longer example. Let's run this code to ensure that we don't have any syntax errors. Our tests are failing, but we only have a stub, so that's what we expect. Now it's time to move on to the template. The purpose of this function states that first we want to filter the list to only include the elements that are from the given location, and then we want to take the average of the water quality index for all the elements in the filtered list. These are two operations that we need to perform on the input, in this case the list, so we'll design this function as a composition. When we design a composition, we don't copy the template from the data type. Instead, we make a note that we're templating based on composition, and then start writing the calls to the helper functions. They may not exist yet, but we are wishing that they did, and we can write stubs for them once we've wished for them. So our template will be return, and then the calls to the helper functions that we'll compose. In this case, what we want to return is the average water quality index, and what we want to pass to the average water quality index function is the filtered list by location. Filter by location needs two inputs. It needs the list of water quality, and it needs the location. Remember that these functions don't exist yet. We're wishing that they did. Before we can run our code, we'll need to write at least the stubs for these two functions that we're wishing for. Also note that in completing this composition template, we've actually finished implementing average WQI for location. Of course, we need to fully design average WQI and filter by location. And once we're done that, we need to run again, check that our tests pass, and think carefully about whether our function is doing what we expect it to do. But for now, it looks like our function design for average WQI for location is complete. As an aside, let's spend a moment considering the fact that we didn't use the input data types template for this function. So far, we've always used data-driven templates, or in other words, templates that are based on the type of input to a function. In this example, we're basing the template on an approach to solving the problem. This is the first time we're seeing it, but we'll see it again in the coming modules. Now you have more than one templating strategy. You may template based on the input type, or you may template based on the problem-solving approach that you're going to take. So far, we just have composition as an option for the approach, but we'll learn a few more in the next modules. Let's go back to the problem that we're working on, and let's complete these stubs for the functions that we wish we had and run our code to make sure we didn't create any syntax errors. Now I need to think about the input to average WQI. I see that it takes the output from filter by location, and filter by location takes a list of water quality and will filter that list to only include the elements at the given location. So it will return a list of water quality. Average WQI for location returns an optional float. And we can see from line 8 that it's returning the result of average WQI. So that tells me that this function also needs to return an optional float. For the purpose, we can say return the average water quality index for elements in LOWQ, or none if LOWQ is empty. For the body of the stub, we can say return 0.0. We can choose any float or the value none, and that would match our return type. Now let's do a stub for filter by location. I can see we're passing it LOWQ, which is a list of water quality, and we're passing the location as a string. And we know that filter by location's output will be passed to average WQI, which is expecting a list of water quality. For the purpose, we can say return the list of water quality ratings in LOWQ from location. For the body of the stub, we just need to return something of list water quality, so we can return the empty list. Now let's run this code and check that we haven't introduced any syntax errors. We have not. We still have our tests failing, but again, we haven't completed the helper function design, so that's what we expect. Both average WQI and filter by location are functions that you could design based on the knowledge that you already have. So I'm just going to cut and paste in final function designs. Okay, we now have complete function designs. And in completing those designs, I actually found an error in my design for average WQI for location. Let's look at that first, and then we'll quickly look at the helper functions. In designing the helper functions, I noticed that the value I was expecting for the tests on line 53 and 54 were incorrect. I had been looking at the wrong part of the data examples. So these examples have now been updated with the correct values. Let's look at these helper functions. So average WQI has two accumulators, a sum and a count, sum WQI and count, and it goes through the list, adds up the WQI for each element in the list, counts every element that we see. Then if count equals 0, meaning the list was empty, it has to return none, and otherwise it can divide the sum by the count to get the average. Filter by location, as you can see, needed a helper function. So for every element in the list, we need to check if its location matches the given location, and if it does, we add that element to our accumulator. Then when we've checked every element in the list and reached the end of the list, we can return the value stored in the accumulator. Let me scroll down so we can see that we have examples and tests for all of these functions. And you can see that our tests are all passing. So now we've completed our example, and we've seen how to implement a function based on function composition, and how we introduce that composition at the template stage.